Alright, we're back out here, and we're just going to do a little layout stuff today. I did get a couple parts in, and I was able, it's like 20 degrees out here, it's freezing. But hot rod building's got to go on. So I did get the plumbing ran for the coolant tank today. And I'm going to show you this some planning put the motor in. So we're just going to look over some stuff and get the gist of how we're going to put this thing in here. So the header flanges, got these off eBay. Speedway sent them, they were 50 bucks. They got the 1 3/4 holes, 383, 400, 440. They'll all work. I'm gonna grab one of these tubes. You can see how it's gonna work. So I'll be able to make a set of zoomies with these header flanges and the pipe. Should be able to make a pretty custom exhaust. I gotta buy a couple more things, but this is a big thing to show up. Once we actually get the motor in there, we can make it look cool real fast. All right, I'm gonna go show you the overflow coolant lines. All right, so I've put the coolant line in. I drilled some holes, and I got wire ties holding it in the framework for the radiator. See the wire tie there holding it. So this hose runs out when the pressure gets past that spring for the radiator cap. It'll puke it. It'll come all the way down, and there's a tube right here that comes right even with the bottom, and it'll fill that fluid all the way up till there's a longer tube that ends right about here. When that level gets too high, it'll come out and let it go straight to the ground down this hose. So it'll allow it to suck in and out when that opens, suck in and out, and have a reservoir of, I think they said like 13 ounces to suck back and forth. If you don't have that, if the cap over pressurizes and you shoot it straight to the ground, then the coolant level starts to drop in here. And when the coolant level drops, then you no longer get proper flow through the radiator. It like spits it in and out. But we want to have this thing full all the way to the cap. Plus the cap doesn't pressurize or work right with an air gap and not a fluid all the way full. So we want this to be able to suck. If it does open, over pressurize, then it comes over here and then it can suck it back in and move it in and out. But we need to have enough volume over here, and then just let it to the tank, let it to the atmosphere, let it on the ground. Now you never want to put this line where it's going to shoot it out underneath like the rear tire. So you want to put it towards the inside of the car, especially if you're building a drag car or a race car or something like that, or a really hot street car. Because if you put that down and it goes under the rear tire and you're giving it hell, next thing you know, you found a wall or a tree, or it's dead sideways and you got no traction at all because you've covered it with slippery antifreeze. Anyway, the whole radiator setup's done now, so we're ready to work on putting the motor in. I'm going to show you the thought process, and because we're starting over, right? We're making our own motor mounts, we're making our own transmission mounts. How do we set? How far? What can we get away with in putting an engine in? Cockeyed. How do we set the level? I'm just going to show you some thought processes around that today. All right. All right. I got a square coming up, and I found the center of my pinion shaft here, and what I'm going to do is I'm going to go from I've already done it, so we'll just go through the semantics. So from the frame edge to the other frame edge is 33 3/4 inches, and the center of this is 15 and 7/8. So that tells me that this pinion is offset to the passenger side 1 3/4. So my center line of my motor drivetrain is going to be that 1 3/4 offset to the passenger side. Now we're going to use that to set the rear of the transmission. Now I'm also going to measure up to get the height here on that rear end housing. So what I really want to do here is find the angle, which I'll do that with a protractor here in a second, of this housing. I already know it's 0. Well, I'll put the protractor up and show you. So it's 0 this way, 0 degrees with the ground. So the motor and transmission we want to have on that same 0 degree angle, but we want to have not in line with that pinion right there. We want to have it 2 inches above, 2 to 3 inches above. And the reason why is when you put a lot of rotational force on that, you know, like the motor's trying to spin that wheel up, this actually twists up to like 9 degrees. So at 0 here, it's going to twist up. We want to have the transmission, you know, 2 or 3 inches higher. So when this twists with a lot of power, it comes into the same plane as where the transmission is. So we're going to get this height, and we're going to make the motor and transmission 2 to 3 inches higher, and we're going to make it, the back of the transmission has to be the same offset, the 1 3/4, you know, off the frame, just like where this is. But the front of the motor can be up to 3 degrees out, so you can be 2 inches cocked either direction, as long as the back of the transmission output shaft is, you know, 2 to 3 inches higher and the same exact offset in the frame. So our 1 3/4 to the passenger side. And that's how we're going to set. Basically, the back shaft of the transmission is the most important. So I'm 12 inches high there on the pinion shaft. It's kind of hard to get a good video down here, but I measure up. I'm 12 inches off the ground to the center of that pinion. So I'm 12 inches high. So I want to shoot for 14, 15 inches high with the back of the tail shaft of the transmission when I place it inside the cab bed here. And then with the protractor, I want to find that I'm 0 on my shaft here. So this angle for my pinion shaft matters. The transmission has to be the same angle. But when this thing gets a lot of power, it tries to rotate like this inside that frame. The nose of this actually goes up to 9 degrees. And see, 9 degrees is that much. That's how much this, and with those springs, leaf springs and that, it'll rotate. So we want to be higher with the motor so that this U-joint turns into that, you know, goes up into that plane. We don't want it to cock. That's the reason why the motor trans gets set in higher in the frame. So now we know all this. We know this is 0. Well, I'll show you where I'll get my measurement for that. And we know from the frame rail over to the center of the yoke, I got 1 3/4 offset in the frame. So the back tail shaft is where all these measurements matter. Okay, so this is the vac tail shaft of the transmission on the motor. And I've got this old shaft yoke set up, and this will actually end up being part of the drive shaft because I have to have one made. It cost me $400. We'll slide that onto the output shaft of the transmission, so we know we're in line with the output shaft of the transmission, which that directly couples to the crankshaft. So basically that's the alignment of the motor. I'm going to take this V block, I'm going to set it on there, and then when I go to put the motor in, we'll align this to be 0, like we know the rear end is 0. So, you know, when we put it in, we'll have this here where it says 0. So the motor would actually have to be cocked. We're just sitting on the ground right now, but this is very important, because if you notice, this thing only moves that much. You know, it only moves that much. That's the end of its rotation. So we want to have this motor shaft, we want to have this, the center line of this, at 14 inches off the ground. And we want to have this output shaft at 0, the match. You know, that way when that rear end rotates up, it'll rotate into the plane, the 2 inches higher plane of this transmission shaft. And this, the center line of this shaft, is what we're going to make our 1 3/4 offset. So whatever the frame dimension is where this ends up in, it'll be 1 3/4 offset. So this is in line with the pinion. It's 2 inches higher than the pinion, but it has the same angle. And that's, you know, how you know you put the motor in right. Well, everything's off of this. I just showed you how to do it. You get everything off the rear end, what your offset is, whatever your pinion angle is. You match the pinion angle, you match the offset. Now the front of that motor can be cocked 2.5 inches either way. You can be 3 degrees. So you know, the motor can be in there like this. It could be in there like that. The clear whatever you need to clear, but as long as this is in line in the back, you can be up to 3 degrees off like this from the back to the front. So the front of that doesn't really matter as much. And with what I got going on here, I should be able to put it exactly 1 3/4 offset. But if I come into a problem with the exhaust you know, if I had exhaust manifolds or you know, the power, I've fixed all these issues, the steering linkage, the power brake booster. If they do come in, I can move the front of that motor 2 or 3 inches over and have it cocked in the frame. But this is the next step. We're going to put it in, and we're going to get this, you know, the 1 3/4 offset in the frame. We're going to get that angle, and as soon as that stuff's right, we'll look at what the front is, and we'll make transmission and motor mounts. Hopefully that's all as clear as mud, so you can see. But you know, as long, you know, on a drag car, that rear end, or even a race car, if you're even a street car, and that's the reason why pinion snubbers on the front of the rear ends work so well, because when that rear end starts to come up, it hits the frame and it can't, you know, it can't unload the rear end. And it keeps this yoke and everything straight. So it only can come up so far with a pinion snubber when you put it on the rear end. So you never want to have this dead straight. You know, my 12 inches that I measured back there, we would never want to set that 12 inches. We always want it higher than, you know, the 12 inches that we measured for the yoke in the back. And hopefully, you know, you understand when that comes up, it'll roll into the plane, And this thing, you know, won't. So right now we're going to be pointed down like this, and when the rear end starts to rotate up, it's going to rotate into the spot. And where we're giving it hell, where we're putting all the power to it, this thing is going to be more in line. And it's going to be more likely to actually hook and not have major vibration issues. And so this needs to be straight, you know, in line with that, so we can actually use our yokes to our advantage and not have them bind, or worse yet, through the drive shaft and pole vault, you know, the truck or the car that you're building. All right, I just wanted to go over that. I'm ready to shove it in now that I got all the measurements. It may take a couple times of me putting it in and out and cutting the firewall, and it kind of sucks because that gas pedal, the hole that I have in my tunnel right now, is actually it's offset 2.5 inches, because Chrysler, when they had this motor in here before, in the truck before, they had it cocked almost the full 3 degrees. So we may end up having to just eliminate the stock gas pedal, welding the holes up on the firewall for it, and getting a hot rod gas pedal and moving it over to make that firewall. It's probably going to happen that way, but I may shove it in there and see where I'm at and see how bad it is. But I'm guessing this is I'm gonna open it up. When it comes to the firewalls, what I've found from building cars is, if you think that, even if you have the transmission in there and you're like, oh wow, you know, I'm gonna make it real tight, I'm gonna make it real close, give it 2 or 3 inches. You'll love it, because always later you're gonna be like, man, I wish this tunnel wasn't so tight. And especially if you're having to work on a car, put the motor in and out, the paint, and you know, or unbolting it to service it for some reason. So that's probably going to get bigger, and that gas pedal is probably going to be not stock. We'll have to just eliminate it. Another, you know, this happens when you go this crazy with this stuff. But I'll probably just take it off here and just go ahead and cut that out. And this is 2.5 inches over, so I'll probably make it the 1 3/4 to the center and cut a big giant hole, and then shove the motor in. I'll have a jack on the floor. I gotta sweep here a little bit. I'll have a jack on the floor because this end tail shaft is what's gonna matter. We need to have that, the 1 3/4 offset here in the frame wherever it lands, and then we need to have it at that 0 degrees, the same as the rear axle, and then we need to be 14 inches high. So wherever that ends up, you know, if the front ends up okay, you know, being 1 3/4 offset, and it looks like we're going to clear our steering linkage and all that stuff, we won't have to cock the motor in here, you know, cock it in there like so. But we can have the center line of the crank 3 inches off up there, 2.5, 3 inches off in the front, and not have a problem. I think I can get away with just 1 3/4 offset in the frame. All right, I hope that's clear as mud. But we're about to put the old girl in. We know where she needs to go. We got the radiator where it is, so we can get our distance off the front of the fan shroud here. Now I'm gonna want a 2-inch. I got a 2-inch adapter coming and a mechanical fan. So I'm gonna want 3 inches from this mating surface to the fan, and that's going to dictate how far this thing goes back in the firewall. It's all going to be off this. So, you know, when I get it up there, I'm going to measure. I'm going to have 3 inches, maybe 4 inches, because I can always put another 1-inch adapter. And really, I want this, you know, I want that fan, the mechanical fan, I want it, you know, 1 inch away from. I want it close, but I don't want it too close to that fan, so it has to draw mechanically air through it. So we're going to shoot for 3 inches off the front of the face to this mating, to this to there, and then we're going to shoot for the 1 3/4 offset, so this thing's in line with the frame rails, And then the whole motor, this basically the crankshaft here, is going to be 14 inches off the ground. And the hole for that firewall is probably going to get moved over and cut bigger. But anyway, that's what's going to happen. We know all our measurements. We know how we're going to lay it out. And the next thing is to shove it in there. I'll probably just go ahead and cut the gas pedal off and cut that frame, or cut that tunnel to be, the 1 3/4 offset there in the frame, and do a little bit of math on where I think this is going to end up to know how high I need to be, and then add 3 inches to it so that I want a 2-3 inch gap all the way around that bell housing, which I'm guessing from my it's going to end up right about this area. So I'm going to have that sticking out, which is nice. This thing won't be buried up in the firewall. You'll be able to service it pretty well. Okay, that's where I'm at. You got any questions, just ask. Should be pretty simple. Alright, check in. Alright, I want to go over something a little bit about that 2 or 3 inches that I was saying up. That's just going to give me a rough start, because it's going to rotate, the rear end is going to rotate in. But when I actually get the motor in, the overall length of the drive shaft is going to matter. What I'm going to do is I'm going to run a string down, or a piece of metal between the tail shaft and that rear pinion, and I really want that transmission to be 3 degrees higher. So whatever 3 degrees is, depending on my length. The 2 inches that I'm doing, the 14 inches high, is kind of a rough spot for me to get. But when I put that in, I'm gonna shoot that down. I'm gonna find how far, and I'm gonna shoot whatever that distance is, 3 degrees from the pinion up to where that output shaft of the transmission is. That way, when that rear it'll shoot from 0 degrees up to 9 degrees. So I want to be 3 to 4 degrees higher. So when it rotates up, that rear rotates up on the back, that I'll have 3 degrees is what I want to run my drive shaft, the maximum angle distance on it. So I'm going to set it right at that maximum, so if that thing rotates up on those springs, I don't have ladder bars on the back. So in springs, they're known to do that. So we want to be able to, if it rotates past it, that we have an extra 3 degrees that it rotates past. So that height, it may be only 13 inches higher, 13 inches, an inch higher, but I won't know that until after I put the motor in and find how far the distance is back to the tail shaft, and then I really want to set that 3 degrees higher in the back. And the 2 inches that is just kind of a rough thing right now, but I just wanted to kind of explain the thought process of why the motor and transmission center line goes higher, because of that can rotate. If you put ladder bars in, it's all, or a parallel 4-link, or all that stuff it makes it stiffer. So you can, if you're going to go that way, put that in. But if you're going to do air ride or something, you really need to think this out on an air ride, on the distance that you need to go. How long is that drive shaft? And know that you really only have 4 degrees that can move. So you need to set that to where my all the way up position and my all the way down position, that I'm really in this happy spot for the U-joint. I hope that helps. But most likely it's probably going to end up 13 inches. But the 14 inches is going to give me a rough start, and the ability to, actually find out what my angle is. I want to be 3 degrees higher, and then if it rotates past that 3 degrees, that I'll have another
3 degrees up that it can go up above that, 3-4 degrees, because it will rotate 9 degrees if you got 1,000 horsepower on a leaf spring car. It'll do it.